Welcome to UPSC Study Academy, empowering aspirants and changing futures. Today, we're diving into the fascinating world of sound. So what is sound? Sound is all around us, from the music we listen to the laughter of our friends, to the chirping of birds outside our window. But have you ever stopped to wonder how sound actually works? That's what we're going to explore today. Simply put, sound is a form of energy produced by vibrations. These vibrations travel through a medium, such as air, water, or solids, and are detected by our ears as sound waves. These waves are created by vibrations, which set particles in the medium into motion. As these particles oscillate back and forth, they transmit energy in the form of sound waves. Sound waves are longitudinal. So, what does it mean for sound waves to be longitudinal? Unlike transverse waves, which oscillate perpendicular to the direction of wave travel, longitudinal waves oscillate parallel to the direction of wave propagation. Longitudinal waves are all around us. When you speak, your vocal cords create longitudinal waves in the air, which then travel to the listener's ear. Similarly, when you pluck a guitar string, it sets up longitudinal waves in the air, producing sound. While studying about waves, it is crucial to know about compression and rarefaction. When we compress the spring together, it represents a compression in the longitudinal wave. The particles are pushed closer together, creating an area of high pressure and density. When we stretch the spring apart, this represents a rarefaction in the longitudinal wave. The particles then spread out, creating an area of low pressure and density. As the longitudinal wave travels through the medium, it creates a pattern of compressions and rarefactions, propagating energy from the source of the wave to its destination. Moving on to the next topic. Characteristics of sound waves. Waves possess several key characteristics that help us understand their behavior. These include wavelength, frequency, amplitude, and time period. Wavelength refers to the distance between two consecutive points on a sound wave that are in phase, such as from crest to crest or from trough to trough. In simpler terms, it's the length of one complete cycle of the wave. The wavelength of a sound wave is closely related to its frequency. Sound waves with shorter wavelengths have higher frequencies, while those with longer wavelengths have lower frequencies. By manipulating wavelength, engineers and scientists can control how sound behaves in different environments. Frequency. Frequency is the number of complete cycles of a wave that occur in 1 second. It's measured in hertz and is inversely proportional to the time period. 1 hertz equals 1 vibration. 1 kilohertz equals 1,000 hertz. Here is a simple relationship between velocity, frequency, and wavelength. Velocity is equal to distance traveled divided by the time taken. We know that frequency is the inverse of time taken. So velocity is equal to the frequency multiplied by the wavelength. Thus, the velocity of a wave in a medium is equal to the product of its frequency and wavelength. Amplitude. Amplitude plays a significant role in determining the loudness or volume of the sound we hear. Amplitude refers to the maximum displacement of particles from their equilibrium position as a wave passes through a medium. In simpler terms, it's the measure of how loud or soft a sound is. Time period. Understanding the time period is crucial for grasping the rhythm and frequency of sound. The time period of a sound wave is the duration it takes for one complete cycle of vibration to occur. In simpler terms, it's the time it takes for a sound wave to repeat itself. The time period of a sound wave determines the pitch of the note. A shorter time period corresponds to a higher pitch, while a longer time period corresponds to a lower pitch. Production of sound. There are various sources of sound in our environment, ranging from natural phenomena to human-made devices. In humans, the larynx, often referred to as the voice box, is a complex structure located in the throat. It's comprised of cartilage, muscles, and vocal folds, and it plays a crucial role in producing sound for speech and singing. When air from the lungs passes between the vocal folds, they come together and vibrate, much like plucking the strings of a guitar or violin. As the vocal folds vibrate, they produce a fundamental frequency determined by factors such as tension, length, and thickness. This frequency is perceived as the pitch of our voice. Additionally, the shape and size of the vocal tract, including the mouth, throat, and nasal passages, influence the quality and timbre of the sound produced. This phenomenon is known as resonance. Sounds on Moon and outer space. Let's start with the Moon, Earth's closest celestial neighbor. Despite being devoid of an atmosphere like ours, the Moon is not completely silent. However, the absence of air means that sound waves cannot propagate as they do on Earth. Without a medium to transmit sound, any noises produced on the Moon would not be audible to human ears. Now, let's extend our exploration to outer space beyond the Moon. In the vacuum of space, sound cannot travel at all, as there is no medium for it to propagate through. Despite the portrayal of explosive battles and roaring spacecraft in movies, the reality is that space is eerily silent. Speed of sound in different mediums. In gaseous medium, the particles are widely spaced and move independently of each other. As a result, sound waves encounter the least resistance in gases, allowing them to travel at relatively high speeds. Specifically in dry ice, sound moves at the rate of 346 meters per second. In liquid medium, sound travels at a slower pace. In water, sound moves at the rate of 1,437 meters per second. And in solids, sound travels through tightly packed particles that are held together by strong bonds. As a result, sound waves can propagate rapidly through solids. And we are at the end of this video. Thank you for watching UPSC Study Academy. Like, share, subscribe, and don't forget to hit that bell icon.